All right, so today I will be giving a very high level overview of different epidemiological and some statistical concepts that are really useful in sort of the work that I do when it comes to substance use prevention research among adolescents. So, a quick agenda of what we're going to go over today. We will start with a just definition of like what is epidemiology. Then we'll talk about what sort of research questions look like when it comes to epidemiological research, and then end on all the sort of stats and interpretations. So, what exactly is epidemiology? I had to also look this up myself. I feel like I know what it is, like conceptually, but I was like, what is the actual definition? So the CDC defines epidemiology as the study of the distribution and determinants of health-related states among specified populations and the application of that study to the control of health problems. So essentially understanding, patterns of disease and patterns of health related states, as they would say, and then using that to design prevention and interventions. That's basically public health in a nutshell. So how does this then translate into the public health research that is then done? Here is an example research question that I sort of pulled, and this is something that my mentee is sort of working on. So I thought it would be a good example to show as our example to carry us through this presentation today. So an example of a research question that, I oftentimes come up with something similar to this is, for example, does e-cigarette use differ among adolescents who do or do not have depressive symptoms? Now, I do want to say a quick caveat that this is an oversimplified example here. The terminology used, again, very simplistic. Do want to say that and acknowledge that depressive symptoms occur on a continuum, but just for the purposes of this example, and to make sense of the different terms, I am just using very simplified language. So, two main things to sort of identify in these research questions, especially for epidemiological purposes, is there's usually some kind of exposure and then some kind of outcome. So, in this case, that exposure or the independent variable is the depressive symptoms. And then the sort of health related outcome or the dependent variable is e cigarette use. So, the first term that I want to define is prevalence, which is the proportion of a population with whatever outcome it is that you're looking at. So, in this case, we're looking at e cigarette use. So, for example, if we had 100 adolescents in our population of interest, and we identify that 30 of them are using e cigarettes, our prevalence would then be 30 adolescents among the 100, or otherwise 30%. So the prevalence of e cigarette use would be 30% in this population. The next number that is used a lot in epidemiology is an odds ratio. So this is the measure of the odds of the outcome happening in one group compared to the odds of the same event or that same outcome happening in another group. Again, this sounds kind of weird and abstract, but I'll give it or apply it back to our example. So again, this is, I'm not going to get into 2x2 tables. That's like a whole nother, that can be like a whole course for epidemiology. But just for the purposes of this, again, made up numbers, but I took our 100 adolescents and sort of assigned them to different squares in this 2x2 table. So they're either adolescents with or without depressive symptoms and either use or do not use e-cigarettes. And the way you calculate the odds ratio is that you take the odds of the outcome among people who are exposed and then divide that by the odds of the outcome among the people who are unexposed. So in this case, you take 20 over 30 divided by 10 over 40, and then you do the math, it turns out to be 2.67. That is your odds ratio. Then what do you do with this number, 2.67? What does that mean? So the interpretation of these numbers is almost just as important as what the number is itself. So the way that you interpret the odds ratio is that you can say it like this for this specific research question. So adolescents who have depressive symptoms or your exposure have a 2.67 times higher odds of e-cigarette use, which is your outcome, compared to adolescents without depressive symptoms. And it's really important here to include that comparison group because that's who you're comparing. It's like among people with and without those depressive symptoms. So our odds ratio was a 2.67. It was above 1. What happens if your odds ratio is below 1? So between 0 and 0.99, or basically all the way up until 1. Because an odds ratio can range anywhere because it's a ratio between 0 and infinity. But in this case, what happens if it's between 0 and 1? Again, this is a made-up example, but let's say adolescents who have whatever exposure you're looking at have a whatever your odds ratio is. So in this case, I made up 0.05 times lower odds of the outcome compared to adolescents without the exposure. So it's instead of having a higher odds, you have a lower odds when your odds ratio is less than 1. So I sort of showed this earlier, but how do you get this odds ratio number? You can do it manually, like I said, by calculating those 2x2 tables, or there are many statistical softwares out there, such as R, and you can run logistic regression models, which are meant for binary outcomes. So things that are either like a yes, no, you have it, or you don't. So in this case, that is yes, e-cigarette use, no e-cigarette use. And then those logistic regression models will help get you your odds ratios.
What is a logistic regression? Yeah, is it just for odds ratio or like what other numbers does it give you?
Oh yeah, you can do it for like so if it's a continuous outcome, so like let's say, because for this case it's binary because I'm trying to keep it simple here where it's like yes, no, you have it or you don't. But let's say it's like how many days do you use e-cigarettes? That would be a continuous number because it would be like 1, 2, 3, 4, 5, like all the way up. And then that you would get a relative risk, which is sort of similar to an odds ratio, but not. But yeah, there are other sort of like ratios that you can use to calculate risk, and an odds ratio is just like one type of those risk ratios. And then let's talk about statistical significance. So this is also something important to consider. Okay, you do find a difference between two groups, or you do have a odds ratio. How do you know kind of its meaning and whether it's showing if there's a true difference between what you're comparing? So generally, if you use R and you calculate, or sorry, you use R and you run the regression model, it'll give you the coefficients, which you can then turn into odds ratios, and then they'll be associated with p-values. So if your p-value is less than 0.05, that's generally the cutoff for being statistically significant. Now, what does that mean, like a p-value of 0.05? So that means that the probability of observing that effect or like that odds ratio that is merely attributed to random noise or just randomness in general is only 5%. Let's say you had like 10 people and those 10 people just have like wildly different like health behaviors. You might get like a really high odds ratio. So generally, like when you have like a large population or a large sample size, you have less of that random noise because you have like less outliers and people being really random. Some more discussion about statistical significance other than just p-values. So there's also what's called a confidence interval, which is a range of likely values for the estimate. So in this case, your odds ratio. So in general, the 95% confidence interval is what we care about in this case, because it means if we were to take 100 different samples and compute a 95% confidence interval for each sample, then approximately 95 of the confidence intervals of the 100 will contain that true value. So it's kind of similar to that like p-value of like 0.05, but in this case it's saying like 95 of the 100 confidence intervals will have your true value. So again, it's likely not going to be due to randomness. It's like truly an association that you see. So interpreting confidence intervals. So if your confidence interval does not include 1 for an odds ratio, then it is statistically significant. Again, this is for odds ratios. I don't explicitly have that here on the slide. But for odds ratios, if your confidence interval does not include 1, it is statistically significant. So for example, if we had our odds ratio of 2.67 and your 95% confidence interval is 1.5 to 3.5, then it would be statistically significant because 1 is not a part of that confidence interval. Now, if your confidence interval does include 1 for your odds ratio, then it is not statistically significant. So for example, for our odds ratio of 2.67, if your confidence interval was 0.05 to 3, then it would not be statistically significant because 1 is inside of that confidence interval. So generally, the way we present a lot of these findings, in papers, posters, etc., generally people care about the prevalence that you find. So again, that like 30 or 30% of people who use e-cigarettes out of the adolescent population of 100. Usually you provide sort of the actual count, so 30, as well as the percentage or the proportion. And then when showing the associations, it's good to always have the actual estimate or the odds ratio or whatever risk ratio you're showing. So in our case, that was 2.67, providing some kind of confidence interval. Again, these are completely made up. So 1.5 to 3.5, again, significant because it doesn't include 1 for an odds ratio. And so I, again, made up a p-value. It's always good to display p-values as well. And as you can see here, I've chosen a p-value, a fake p-value that is less than 0.05, meaning that it is statistically significant. And that's everything. So again, very quick, just sort of Epi 101, really odds ratios 101 versus just epidemiology. And if you're interested in learning more about kind of other types of relative risk ratios, et cetera, there can be more follow-up lectures on that. But for now, I mean, I find myself using odds ratios a lot for some reason in my substance use work, maybe because I really care about if people use and do not use substances. So I would say a lot of my analyses fall into this category, which is why I wanted to present on this today.